Good morning, everyone. Today I'm going to do assignment 1, of which after finishing, I'll have to send it to you to send the link for the recording. So, question number 1 on assignment 1, it says which of the following is a linear equation x and y? So, and we're given we're given 4 options there. So last time I told you that linear systems you can see by having the variables without the exponent. For example, we have number 1, wherein we are given x minus e squared y equal to 3z, and we are also given that e is a number which is equal to 2.71. So now let's check. Do we have variables with exponents here? No. X is not, it's just having an exponent to 1, which is fine. So that is linear. Y is having an exponent to 1, Z is having an exponent to 1. Therefore, that is the correct answer which we're supposed to use. We don't consider this, but that is just a number. So e to the 2 is a number. Therefore, the answer is option 2. Let's investigate about the other options we have here. So we have 2 pi lean into e to the half minus 2y plus z equal to ln of 3 minus x. So why this is not linear? It's not linear because you can see that the variable z is on the exponent. So that's why we see the equation is not linear, because of this term. Otherwise, if it's not that, everything was going to be perfect here, because y is not having an exponent of any number other than 1. Same with z and same with x. So the problem is here where z is on the exponent. And the number 3 is not an option because of the first term that we have there, of which I believe you can see that it's having an exponent of -1. So hence we say 3 is not linear. Option 4 is not linear because of the term we have on the right hand side is having an exponent of 3. Hence, the answer for the first question is what? It's 1. So for question 1, we have an answer of option 1. And then for question number 2, this is exactly the same question. I don't know why he repeated the question. It's the same question. So that's why we still have the answer for that question as 1. And then for question number 3, we are told which of the following is a non-linear equation in x, y, and z. So we're supposed to choose the option which is non-linear in this case. So let's investigate. So the first option we have there is y plus zy minus 2z, which is equal to 7x. Is this linear? Yes, it's linear. It's not non-linear. Therefore, we are not having any problem. But remember to investigate about the linearity of the equation after adding the like terms, which this we can add them together, and then you will see that 1 is linear. And then 2, is it linear? It is not linear. Why? Because of the exponent z there. So you can see z is on the exponent. So 2, it's a non-linear term. Is it option 2? Let me check. Yes, option 2 is the one which is non-linear. So option 2 is the one which is non-linear. And then option 3 is linear because x, y, z are not having exponent other than 1. And then option 4, again, variable x, variable y, and variable z, they are not having exponent. So, but there's something interesting which you're supposed to investigate further there, wherein we have the multiplication of x and y. So that will pose a situation wherein we have non-linear equation. So you might have 2 options here. So the first option is 2, and then fourth option the second option is 4 because of the product of x and y. So that will also cause the non-linearity of the equation. But option 2 is the best option which you can choose there because z is on the exponent. And then question 4, here is interesting part of which I haven't covered with you as yet. So let me wrap here and explain. Question number 4, wherein we are told that any homogeneous linear system has one solution or no solution. So we're supposed to choose an option wherein any homogeneous linear system has one solution or no solution. So we're supposed to choose an option for that. So that statement, you must get the conclusion, and you must also get the initial statement of that. So the initial statement in this case is one solution, and then the conclusion is no solution. Therefore, one of these statements you must name it true, and then the other one you must name it false, because they're contradicting statements. So let's say in this case, one solution, we name it T, and no solution, we name it F, where T stands for true and the F stands for F. This is what is called logic gates. I didn't cover this chapter with you, but because it's there on the questions, let me do them. So here we're supposed to find any homogeneous linear system as one solution. Which statement is it going to be true? Which option are we supposed to make? So homogeneous linear equations, we know it must have just one solution, like what we have done in this case. Let's say we are solving simultaneous. You will see that you're going to get just one value of x and one value of y. Therefore, a linear system, they have only one solution. There is no situation where in linear system don't have solution at all. So in that case, we'll be dealing with a non-linear situation where you cannot find the solution of that specific. So in the 5 options we're given here, we are looking for the one which will give us a true statement. And I can tell you from the 5 options, it's only one which is going to give us a true statement. So let's investigate. We start with the first one, wherein we are having a table of true and false. And for option 1, we are having a conjecture and. So what does M stands for? Remember, I haven't taught you this chapter as so it means I will have to explain some things in. So we're having conjecture N, of which this simply tells us that both options must be true in this situation. So if one option is false, therefore conjecture is going to make the whole statement be false. If both statements are false, so it's going to be false. If both statements are true, it's going to be true. So here we have, let me put this down here. So true and false. So let's investigate this conjecture. So if we're having true and false, so it means the statement is going to be what? False. Because for this statement, for this conjecture to be having an option of true, both statements must be true. Therefore, this is false. It's not an option that we're looking for. Then let's investigate the second one, wherein we are using the true triple again. So we are having true and false. Then we start with false or false, and then not true, and then the conjecture of false or false and not true. So with this, we have conjecture of false or false. So this conjecture of or, this is and this is or. So one of the option, if it's true, therefore it's going to be true. But if both statements are false, therefore it's going to be what? False, like what we have here. So we have false or false, therefore it has to be false. Not true is the opposite of true, which in this case is false. Therefore, the conjecture we're supposed to investigate is for the solution obtained here and the solution obtained there. And you can see we have a conjecture and which accommodate this and also that. Therefore, if we have and one statement, both statements must be true for the statement to be true. And if one of them is false, therefore it's going to be false. So let's investigate here. You can see both of them they are false. Therefore, we have to have what? False. So let's go to option 3. Remember, we're investigating the option we're supposed to choose in. So we have true, and then we have false, and here we have not false, and then from there we have not false or true, and then from there we have false and not false or true. Okay, let's investigate this. Not false for sure, it has to be true. And then from there, not false or true. So let's check. Not false is true, and then true in this case. So that must be true. And then after having that, we then have to investigate this with that. So of which if we have n, both options must be true. Of which you can see this one is false, which simply tells us that this must be what? Must be false. So it's not an option only. Now let's investigate the fourth option. Wherein here we have true, we have false, and then we investigate the conjecture true or false, and then after having conjecture true or false, you then have to investigate and. Already this is false because you can see we have false then, but let's investigate to see that. So for true or false, one of the options must be true. Therefore, this will be true, and then from there we have true for this option and false. Therefore, it's false because for n, both options must be true. Then the last one, of which this is a must to be true. If it is not, therefore there's a problem. So we have true, and then we have false, and here we have true or false. Then from there we have true or false or false. So here we're going to have true because we have that conjecture, and then true again we have that conjecture. If this is true, therefore true, false, if is that conjecture, therefore it's true. Therefore the option for that it have to be option 5. The option 5 is the answer to that. So other ones they are false, therefore the last one is the one that is. So we do exactly the same thing even for question number 5, question number 6. You will use exactly the same approach in order to get to the answer. Okay, let me investigate so that you can see how we get to the answer. So I will use the same table so that we don't waste too much time. For the first one, true and false, it has to be false for that option. So the first one. Then the second one, we have to investigate is false and false. And they're not true. So we are investigating a situation wherein any homogeneous linear equations has no solution or infinitely many solution. Yes, again, here we can have a situation where we have infinitely many solutions when number of equations are more than the number of variables, or either way around. When number of variables are more than the equations. So I think I've given you that example. For example, we can have x, y, z equal to 1, and then 2x plus 3, 1 plus 7z. Let's investigate this scenario. We have two equations, and how many variables do we have? 1, 2, 3. Therefore, we have many variables as compared to the number of equations. So this kind of linear system is not solvable. So you are going to have infinitely many solutions. I've given you a scenario about this situation of what really happened. So you're supposed to let one variable to be certain variable of which it must be a real number in order for you to investigate the infinitely many solutions. But this is the situation that we're going to have. Therefore, that statement it must be true, because if you say no solution is true, then infinitely many solutions must be false in that case. So let's investigate to see what we are going to obtain for that. The first one is false, and then the second one we have false and not true, and then the conjecture of not false and not true is going to be false in that case. So for option 2, we have not false, which is true, and not false versus not true, which is true, and then false in that case. And then for option 4 is not true. Do we have an option for not true? No, so I have to take it from option 4. So we're having not true and then not false. And then from the conjecture of not true or false. And then the last one is not true versus false versus not false. So here is false and there is true. Then from there, not true versus false, not true is this versus false. So false, false, this is false. And here we have this conjecture and not false. So if we're having a conjecture of or and this is false, then that is true. Therefore, it's going to be true in that option. So the answer for that is a must that it must be option 4. For that is this option that we have. The last one, it must be false for sure. All right. Question number 6. Let me wrap here. Okay. For option number 6, we are having true, false. And from there we have true and false. This conjecture is true when both options are true, but you can see one of them is false. Therefore, it must be what? It must be false. And then for number 2, we have this is 1, and then for 2. Remember, we're investigating a situation where in any homogeneous linear system is one solution or infinite solution. So it's going to be the answer for that is infinitely many solutions. Because here we are given a situation where true stands for T stands for true and F stands for false, and the symbol for it. Okay, no, it's fine. So let's investigate this. We know the answer here must be true because the equation is going to have infinitely many solutions. So here we have true and there we have false, and then from there we have not true and then not false for the second one, and then we investigate not true versus and not false, and then the last one is not true and not false or not false. Here is false, here is true. And from there, if we have and, therefore this is false. And then this with not false, one of them is false, therefore it's going to be false. True, because of this conjunction. Or therefore, that is the answer we're looking for. It must be option true, because it's true. Otherwise, they're going to be false. All right. Question number 7. Determine which of the following is true set of the linear equation below. Okay. Yeah, this is the situation where infinitely a many solution. So we have 3x minus 1 plus z is equal to 2. We're supposed to let 1 to be equal to t and z to be equal to s. Substitute this there, you make x this with the formula, you're going to have 3x is equal to t minus s, and then you divide both sides by 1 over 3 into with 2 plus 2 here. So we're going to have 2 plus t minus s. Which option is this? Is it first, second? 1 over 3, t positive, 2 positive, s negative. That was option 1. It's not option 2, it's not option 3, it's not option 4, because you can see we've done the calculations. This correlates with option number 1 on question number 7. Question number 8. Let me wrap everything. Question number 8. Consider the system obtained from argument matrix below. I believe you remember this situation. In our case, previously we used the dots. You can also use the solid line like this. Consider the system obtained from augmented matrix. Choose the correct statement. So which one is going to be a correct statement here? Okay, let's investigate what you have here. So if the determinant of this is equal to 0, therefore we are not going to have what? Solution. And the determinant of this can be 0 if you remember the multiplication of 2 by 2 matrix. If we have A, B, C, D, we find the debt of A. This, you multiply them together, you get AD. This, you multiply them together, you get BC. Of which, if it's equal to 0, you're not going to have solution, because that would be invertible matrix. I've told you before about that. I wanted to use this. It's A, B, D, C. Okay, they use DC, D here, and then E. So it's gonna be AE minus BD, of which AE will be equal to BD for us not to have a solution, because if that is equal to 0, we have an invertible system of which you cannot find the solution. So if AE is equal to BD, then we don't have a solution for that. So let's choose the correct answer amongst this we have here. So the first one, the first option, the system has no solution if AE is equal to BD. Exactly what we find here. Therefore, the first one is the answer. The second one is not the answer, because we know if AE is different from BD, we are going to have solution in this case, and there might be infinitely many solutions. So there are two options. It might be infinitely many solution or one solution. So we are not really sure if it's going to be infinitely or one solution. And then the next one, the system is inconsistent for, we don't have F from the system, therefore we can't even attempt to investigate about that, because F is not given there. Even on option 4, we don't have F. On option 5, we don't have F. So therefore, we cannot talk about those ones at all. And then question number 9, consider, given the system obtained from the argument matrix is the same matrix, so now we are told the correct set is infinitely many solution. Can't talk about it because we don't have F. Option 1, 2, 3 can't talk about them because they don't have F. And then option 5 we can't talk it about because it's having F, which we don't have on there. So the correct answer in that case, it must be option 4, because we have actually it's sort of like a repetition of the first question number 8 that we have done there. So the system has no solution if A is equal to BD, and I showed you that if the determinant is equal to 0, we can't get the solution there because the debt is going to be 0. You remember when we find the inverse of the matrix, 1 over debt of A, you interchange this is going to be E, B, and it's E, A, and then negative B, negative D. So if that is equal to 0, it means the sum is going to be 0, and you are not going to get the inverse matrix of that. So therefore, you can't obtain the solution for such kind of system. Hence, we are saying that option 4 for question number 4 is going to be a situation we are dealing with. And then consider the following linear system. For question 10, we are having 2x minus 3y, which is equal to -1, and then 2x minus 3y, which is equal to 1. So which one is the correct answer for this? Again, you will solve this by using whichever approach. Even simultaneous can work in this case. If this is question number 1 and question number 2, you add this together, you're going to get 4x, and then that side, you're going to get a 0. Therefore, x is going to be equal to 0. So after this into one of the equations there, it's going to give you, this will be 0, and then we will have y, which is equal to 3. You have done it incorrectly. Edit this without this. Okay. Let me see. Okay. Let's take it from here. Let's see what's going to happen. If we subtract here, if we subtract these two equations, both variables are going to cancel. X, y are going to be 0. If we add, we're going to have the same situation. So in that case, let's see what we get for x and y. So we're going to have x, which is going to take everything to the side. It's going to be 3y plus 1 divided by 2. Substitute this into one of the equation. We're going to have 2 into 3y plus 1 divided by 2 minus 3y, which is equal to -1. This that 3y plus 1 minus 3y, which is equal to -1. This cancels. Therefore, y, it cannot be equal to -1. You see, we have proved that we cannot find the value of x and the value of y. Therefore, in that situation, we're going to have infinitely many solutions for that question. We can't have one solution. It could be one solution if we were in a positive there, because we're going to add, we get the value of x and the value of y. Coming. Next one. Yeah. After 30 minutes, I'm done with it. Then, oh, in which later. Oh, okay. Try to skip. Next door. I don't know the number, but it's yeah. Next door. Those are my conditions. Okay. Sorry about that. Previously I said question number 10 is option 2, thinking that we're going to get the value of x and the value of y. That is not the case. We're supposed to have a situation wherein we have infinitely many solutions, because we can't get the value of x and the value of y. So question 10 must be option 4, because we can't find solutions for such kind of system. And then question number 11, we have a situation wherein we are considering a system of linear equations given as that which of the following is augmented matrix for the above given. I believe you now know how to obtain the augmented matrix for the system of equations. So you have to have something like this here for sure. If we're dealing with 3 variables, it's x, y, and z, and then on the other side, we put the constants that were given 1, -1, and 2, and then the coefficient of x from first equation is 1, coefficient for y is -1, and then there are 2, -1, and 1, and then 1, -3, and -1. So let's check which augmented matrix is similar to what we have up there, and you could see that the correct one, it must be number 5. The other ones, they're not the same with what we have. All right, then after that, we go to question number 12, which is about a matrix again. So we are assuming that we are given a coefficient matrix A of the system of linear equations, where B is given as that, and the matrix A. Solve for the variable x2 and x3 in the above system. So you don't need to worry about this. So we are given this kind of situation already. So matrix A is 1, 0, it's 0, 1, 2, 2, 5, 6, 1, 0, 0. And then we multiply this with the variables that are given here, which is x1, x2, and x3. And then on the right hand side, we have which is 1, 2, and then 4, of which you just multiply this with that, this with that, this with that, you obtain the value of x and 1. Let's start with the last one, because that's where we're going to get the first solution. This, the last equation with that, this with that is going to be x1. The other ones, they're going to be 0. So it means x1 is going to be equal to 4. You skip the second one because you can see saving all variables. You go to the first one. All right, let me investigate this situation. If you multiply the first one, you're going to get x2 plus 2x3, which is equal to 1. And then the second one is going to be 2x2, 2x1 plus 5x2 plus 6x3, which is equal to what? 2. So for these two, you can't get the you can't get the value of x2, x3 without using x1 that you obtained there. You substitute x1 there, you make x2 the sum of the formula in order to question. So let's make x2 the sum of the formula here. You will have 1 minus 2, x3. You substitute x2 where we have x2, we substitute this, where we have x1, we substitute 4. So it's going to be 8. 2 times 4 is 8, plus 5, where we have x2, we substitute 1 minus 2x3, then plus 6x3, which is equal to 2, of which it would be 8 plus 5 minus 10x3 plus 6x cubed, 6x3 equal to 2. You add the right hand and take the other ones to the right hand side. So this with that is going to give you negative 4x3, and then this is 13. You take it to that side, it's going to be negative 11. When you add it with 2, you divide both sides, you're going to get 11 over 4, of which you can then substitute here, you obtain x2, which is equal to 1 minus 2 into 11 over 4. And that will give you 1 minus 11 over 2, which is negative 9 over 2. So let's check. What did we obtain here? We obtained one value for x1, for x2, and for x3. Let's investigate the options that we can choose. System is infinitely many solutions. That is not true. System is exactly one solution. Very true. Because x1, x2, x3, they only have one solution. Therefore, it's option number 2 for question number 12. Question number 13. I'm wrapping up all these things we have here. Question number 13, we are given an augmented matrix 3, negative 1, 5, 4, 1, x squared minus 40, and then 4, 2, lambda plus 2. So how do we go about this? Use the Gauss-Jordan process. Gauss-Jordan is similar with what we're doing for gas elimination. For gas elimination, we obtained the zeros below the diagonal. For Gauss-Jordan, we obtained the zeros below the diagonal and above the diagonals. So it's a similar process which you don't need to worry about. So this question requires us to determine for which values of lambda will the following system have no solution? Don't need to worry about that. So this is going to have no solution when this is equal to 0. The determinant of this is equal to 0. So you just find the dirt of this, dirt of A should be 1. I believe you remember how you find the determinant of 3 by 3. Negative 1, 5, 1, lambda squared minus 40, and then negative 2, 3, 5, 4, lambda squared minus 40, and then minus 3, 3, negative 1, 4, 1. Multiply them together, you're going to obtain negative lambda squared plus 14 minus 5 minus 2 into 3 lambda squared minus 14 times 14 times 3 is going to be 28, 38, 42. Something minus 20 minus 3 into 3 minus 22 plus 22 is 44. For this, to have no solution, it must be equal to 0. We simplify. Negative lambda squared plus 14 minus 5 minus 6 lambda squared plus 84. But let's just add together to simplify things. So this is 22. So it's negative 44 minus, and this is negative 41. So it's negative positive 82. So add like term to give you negative 7 lambda squared. And again, okay, here we are going to have let's take 4, 2. Okay, let me do it this way. We take everything to the other side. So we're going to have 38 is positive 38, and then 33, 43, 47. Is it not 48? Just give me 47. Okay, and then lambda squared. Lambda is going to be equal to negative. Otherwise, if it is positive, it's not given. Or we take it to the side, it's going to be negative. That must be 49. But this is just a matter of, let's simplify it so that I'm not leaving a calculator with me just now. So, but from here, it's just a matter of simplifying. So the option I choose for this question, I said question number 1, I said lambda is equal to 4, which simply tells us that lambda in that case must be 4. So you must get to the answer of 4 in this case. It might be the case because you divide by 7 and then root. So it's going to be, I think this must be 49. But you can investigate further from this. You just find the determinant, equal to 0, you solve for lambda, lambda must be equal to 4. When I did these calculations, I was having a calculator back then. All right. We'll go to the next question, which is about what conditions must the constants be satisfied for the following systems. Okay, in this case, lambda, beta, lambda, and gamma, there must be constants for these to satisfy the conditions for linear systems. So let's check if we have such situation. So lambda equal to beta, and there must be consistency if there are linear equations, and there can be linear system if lambda, beta, alpha, and gamma are all zeros. So in this situation, let's check for the first option there. Lambda is equal to beta, and any value of gamma, okay. And then the second option is alpha equal to negative gamma, and any value of beta, all right. And then the value of x is not unique, and the value of y is not unique, and the value of x, y are unique. So in this case, we're supposed to choose from the above two options. We're supposed to choose from the above two options. Previously, I said question 14 must be 1. Let me check why it must be 1. It must be different from 1. Let's investigate so that we can get the correct answer for this. So I think I did not do further analysis in regard to this previous, but I can tell you the answers. It must be option 1 or option 2. So we have x plus 2y plus 3z equal to alpha, and 2x plus 5y plus 3z must be beta, and 2x plus 7y minus 3z must be alpha plus gamma. The first option is when alpha is going to be okay. Here where we have alpha replaced by beta. Let's investigate and see what happens in this situation. Are we going to be able to get the consistency? The consistency can happen when we have a linear system. Linear system is possible when x, we have linear system, and then again, after having the linear system, we must have only one solution to this equation. For sure, if it is linear system, it gives us one solution. So x must have its solution, y must have its own solution, and z must have its own solution. So for this situation, so we eliminate one variable, we can add them together. We're going to eliminate z in that case. And once we're able to eliminate one variable, then it means it's fine. So we can eliminate variable z here, and then on this equation, when we add them together, we can eliminate variable z again. Therefore, it means that option is going to be valid. Let's test the second option when alpha is equal to gamma. So it means here we're going to have 0, 1, that set is 1. It's alpha. Let's check which option is going to be for that situation. Again, we can eliminate the z. We can also eliminate the z. But if you check for this one, when we eliminate the x, the z, the x is going to be increasing, so it's going to be 4x. And then when we eliminate x, even that is going to increase. That's right. So option 1 and option 2, they're both valid. You can choose whichever option in that case, because both are giving you linear system, of which, if it is linear system, it's going to have only one solution. Oh, and let me remind you of something so that maybe you don't confuse what we discussed on first two questions with these questions. Here we are talking about linear, not just one equation. So there's linearity for one equation and linearity for many equations. So for linearity for many equations, we call it linear system, unlike the situation where we have one equation. So in that case, we call it a linear equation, unlike linear system. So you must be able to differentiate that one. So here we can have solution for question number 14. It could be option 1 and option 2. So option 3, 4, and 5, they can't be valid because you can see x, y are not unique solution. Option 3 is not unique, so we're going to have infinitely many solutions. Option 4, the value of y is unique and y is equal to lambda minus beta. So y is unique, but z and the x, they are not unique in this case. So the last option, the value of x, y, z are unique and lambda. And let me not comment much about this question because I can see even option 5, it can be valid in this case. If x, y, z are unique, so it means they are linear. And once they are linear, you can have one solution in this case, which simply tells us that it's not the consistent. Question number 15, I skipped it because I was not sure of what it really wants us to do. So I did not see the option which we can choose because the product of xy is not the same as the product of yx in this case. Hence, I was confused of which option you can choose for question number 15. I will investigate further with regard to that. If I get an idea, I'm going to tell you of what you're supposed to choose on that one. So question number 16, this is about getting the determinant of a matrix, of which you can get the determinant for matrix given in this form by using this simple formula of 2 to the, it has to be the base that is given the -3 to the power the size of the matrix and then multiplied by the determinant without a value inside. So you can see we're going to have -3 to the power, we were given a size of 4 and then that of matrix. So this is going to be 16 that of A. So the question says, suppose that A and B are 4x4 matrix such that B is non-singular. Which of the following statements is or are true? So we're supposed to choose an option where we have a non-singular. It's going to be singular if it is equal to 0. Then if it is not equal to 0, then it means it's not singular. If it is equal to 0, it means it's singular. If it is different from 0, it means it's non-singular. Okay, let's investigate this option. As I've said, this is the formula which you can use to calculate the determinant. You can see we had -3 there, so you can take out 3 to be this formula. But now, this formula it applies when this is positive. So if it is negative, it's a different story. So hence, this first option is not going to be correct because of the what of the negative. So then the second one, the second option, we have that of 3 inverse beta equal to 3 to the 4 third beta. And then the next question 2, we can't get negative. Option 3, 2 to the. So option 3 is going to be the correct answer. I mean, option 4 is going to be the option that you are looking for. Did I choose option 4 question? Option 3 and option 4. There must be the ones we can choose from. Option 3, option 2 and option 4. They have value. Option 4, it cannot be because it's having exponent 2, but option 2 is having exponent 4 because of the size of matrix. Therefore, option 2 is the one that we can choose from. If option 4 was having exponent of 4, it was going to be correct, but now it's having exponent of 2, so it can't be correct. So now, question number 17 is about the non-singularity. So which option is going to be non-singular? So it's going to be non-singular if the determinant is not equal to 0. So it means you're going to get the determinant of question number 1, the determinant of question number 2, determinant of question number 3, determinant of question number 4, of which in this case the determinant of number 1, you're going to get it to be 0. Terms of question number 2 is the one which is different from 0. For number 3, it's obvious it's going to be 0 because you can see the third row is having zeros there. Again, number 4 is going to be zeros because you can see at the bottom there are zeros and up there are zeros. It means in all rows we're having the zeros. So option 1 is not correct, option 3 is not correct, option 4 is not correct. Because if you get the determinants of those, they're going to be equal to 0. Hence, option number 2 is the correct one that we're going to do for question number 7. And then question number 18 is about getting the augmented matrix first. So of which is going to be 1, 2, 2, 0, 3, 4, 0, 0, -3, and then you multiply by x, y, z, which are multiplied on the right hand side. We have 10, 5, 10, and -3. So you multiply this with that, it's going to give you -3, z, which is equal to -3, then z must be equal to 1, and then the second one is going to be 3, y plus 4z is equal to 10. Where we have z, we substitute 1, therefore it's going to be 3y equal to 6, where y must be equal to 2. And then x plus 2y plus z must be equal to 5. And then here we're going to have x, which is equal to 5, z is 2, therefore it's minus 4, and then minus 1, therefore we're going to have 0. So let's check which one is going to be true. Where in this case we investigated and found x, which is 0, and y, which is equal to 2, and z, which is equal to 1. So which option is going to be correct for this one? Let's check. Is it is number 18? Let's check. I said number 5. So I said x is equal to 0. It must be equal to -1. Let's check how come it's equal to. Okay, I left 2 in. You see, is this 2 that we have there? So here it must be 2, so that it must be -1. Then option number 5, it must be the 1 that we're looking for. Question number 19. We are having a system 1, 2, -4, 0, 0, -3, and x1, 0, 15. Multiply this with that, it's going to be -3y equal to 15. Y will be equal to -5. Substitute there, it's going to be x plus 2, where we have y, we substitute -5 minus 4z. We have z here. Yes, we need to have that is equal to what? Let me check this with that. These two they can't multiply to each other. So you can see we can generate the equations here because this you multiply with this you multiply with that. So we have that component there of which it cannot have the unknown. So we are not going to have a solution for this option. Why? Because we have many we have few unknowns as compared to the number of equations. We have two equations as compared to the number of unknowns. Am I right? We have, in this situation, we have 2 equations and 3 unknowns. Yes, that is fine. The very last question. Use Gauss elimination to solve the system of linear equations obtained from the augmented matrix. Choose which of the following option is correct option. All right. I believe you remember what we're supposed to do in order for us to find the we're using the Gauss elimination to solve the system of linear equations. Okay, let's do that and see where I will get to the answer. So we have 1 1 0 0 0 0 1 1 1 1 3 3 negative 2 negative 2 1 1 and then 1 2 7 1. Okay, let's do this and see how we get to the solution. I told you, in order to deal with these kind of questions, you need to attend to the zeros on below the diagonal. So here 1 2 3 4 1 2 3 4. Okay, that is one. This is the diagonal. So it means everywhere here you must have the zeros. Here, and here. You must have the zeros. So we start with these zeros then, of which you can obtain by saying row number 1 minus row number 2, it must give you row number 2. And then row number 1, you multiply by 2, you add it to the row. Here is row 3, and there is row 3. Then this is row 4, it must give you row 4. So it's 1 1 0 0 0 0 1 1. It could be 0 0 negative 3 negative 3, and then here it's going to be 0. So it's 2 plus this, which is 0. Fortunately, this plus this is 1 1, and then we have 1 2 7 1. Fortunately, we were able to get the 0 then. So we need to get the 0 here, the last 0, of which you can get by saying row 2 minus row 4. It must give you row 4. So this is going to be 1 1 0 0 0 0 1 1 0 0 negative 3 negative 3 1 2 7. This plus that. Okay, let's subtract. This minus that is 0, this minus that is 0, this minus that is 0, this minus that 0. Then this with that is going to give you 1. See, this row is eliminated. The 0 at the bottom is, the row at the bottom is now zeros. You are left with 3 equations and 4 unknowns. That's why we need to choose the what? The last option, impossible, no solution for this equation. Because the last one is what is eliminated. You can't get the solution from this. If you try to multiply this with that, this with that, this with that, it's going to be. So it's no solution, or there are infinitely, yes, you can use this option for. I did not see that there's this option for infinity. There are infinitely many solutions given by. Okay, let's check which those solutions. What are they given by? So it's going to be x plus 1, which is equal to 1, and then z plus, which variable can I use for s? Okay, let me use s equal to 2, and then negative 3z minus 3s is equal to 7, and then the last one is nothing. All right. This equation is the same. Yes, if we divide by negative 3 quarters, we're going to have z plus s, which are going to be equal to different values. But it's okay. Let's let 1 to be equal to, we have two options. The first is when 1 is equal to t, and s, which is equal to, which variable can we see? Gamma. So we'll have x, which is equal to 1 minus t, and then the second one is z, which is equal to 2 minus. So from this, if t is changing, we can have let me check. Yeah, infinitely many, impossible, no solution for this is going to be option 1. Because you can see we let two variables. It's supposed to be just one variable that we have treated in this case, not two variables. So I can stick with the last option there, other than having two options wherein we let two variables to be equal to certain value. So you can see even on option 1 and 2, they only introduce one variable, which is t, not two variables. So we have to introduce one variable, of which in that case is t. So option number 5 is going to be the valid option. So that is all about the assignment. We can go through the assignment again if you feel like you need further clarity. But that's what is all about with regard to the assignment. So good day.